I got this PA amplifier at a antique mall. It's been sitting here for about 10 months. And, you know, it doesn't have, there's no model number or brand or anything on this thing. Not one marking whatsoever. But it looks pretty cool. I mean, you can see it's got a couple of 6L6s in there and all kinds of transformers, so it looks pretty cool. I think I'm going to try to see what we can do with this. I cannot get that out of there. Let me take the bottom off of this thing. So here's what's inside. Wow, all those capacitors are gonna have to go. Look at those things. It just seems kind of like it's kind of floppy. Is that how it was originally? It's kind of weird. You just see it's like just tacked on there. That didn't seem very secure. Wow, look at that. Oh, look at that resistor. Wow. That might be the biggest resistor I've ever seen. What does it say? 20,000? 2,000 ohms? Or 20,000 ohms? 20,000? $461. Wow, all these capacitors have got to come out of here. Ooh, look at that one. It's got leprosy or something.
Wow.
Okay, so anyway, it's not plugged in, obviously. This, I just need to be, yeah, just tighten that nut up there and make that to where I can get that fuse cover off of there. See what fuse is in there. Or should I just turn it on? Just see what happens.
Turn it on.
Turn it on. Leroy's vote is just turn it on. Yeah. There's like 77 and a 461. So those are obviously the people that checked it when it was getting built. Still, I don't see one model number or anything. They were not very proud of their work. This is the inside of the... Here's the bottom. This is the inside. Looks like something was leaking. That's this filter capacitor leaking big time there. Look at that. Onto the bottom. Yeah, I don't know if I should just... Oh, there's a new style capacitor. Someone's put that in there. Leroy's trying to get me to turn this on. Now why? Okay, that one's got taps. The big transformer's got a bunch of taps on it, and then also this has got a bunch of taps. Okay, so I guess that makes sense. This is probably the output transformer, and that's probably just the power transformer. And then the other one's some kind of a choke or something. What do you think, Leroy?
I did not know.
That looks like that has been added. That didn't seem like that's from the same year as this unit. Although the wire going to it does look like the same year, so and they just replaced that jack apparently. It's like a little RCA jack. Yeah, these capacitors are gonna have to go. Oh, look at that. Look at that big old resistor right there. What is that? I don't see one brand name on this thing. Huh. Alright, I'm going to try to tighten this thing up, and maybe we can just bring it up on a variac and a current limiter and see what happens. It also has these mic inputs on the side here. A couple mic inputs, a phono input, and that, whatever that is, it's not marked. What if that was added? It looks like that might be added, maybe? I don't know. Maybe not. It just jumps over to one of the mic inputs. Okay, no fuse. No fuse in this thing. It's just supposed to take 1.2 amp. 1.2? That's weird. Oh, 2 amp. 2 amp. You know, we're going to go ahead and just try to plug this in. It's kind of curious how whoever had this didn't replace that filter capacitor. You know, they've got some pretty nice Mesa 6L6s in this thing. It's kind of weird that they didn't, you know, they changed out a couple of capacitors. Look like they've been changed, like that one right there and that one for sure. Why wouldn't they have done something about that leaky thing right there? So anyway, I've got it plugged in. Got it plugged into my current limiter, and then that's plugged into my variac. So we're gonna see what happens here. Let's see. We're just gonna turn this on, and then we're gonna turn this on, and let's see. I guess it helps if I plug that in. So stand by here. Okay, we should have some juice now. I got it. Let's see. Let's turn that down. Okay, so it's basically turned off at this point. That's on. That's on. This is on, but it's turned down, so we're gonna bring it up. Hold on. Okay, I just got my shop speaker wired up to the output here. I'm just monitoring right now. I'm just got my meter hooked up to the input filament voltage of the rectifier 5U4, just to see what's showing there. And then I've got this on my variac, and this is on here too. So, and then this is on. Okay, let's just see what happens here. Let's bring it up to about 50 volts. Would you mind moving that? It's reflecting on here. Okay. Anything? Is that light on? It looks like that light's on.
I think it's turned on.
Here it is. It's got 2 volts. So let's bring it to about 80. Oh, we got a little bit of light coming on here.
Oh, okay. Yeah, I see it now.
And we're at 2 volts. 2 volts on the filament. Switch those leads over to the output of the rectifier. So let's see what that is. Okay. Got a little bit of, I don't know if you can see that, but a little bit, the light's coming on my current limiter a little bit. Huh. Not much coming out of the rectifier. Got that on there right. Let's give it a little bit more juice. And you can hear that too. It's almost like something shorted. Okay, hold on here a second. Yeah, so I had my meter on DC. It's actually 350 volts already. Any of the tubes lighting up in here? Nothing. There is a little hum.
Yeah, real faint.
A little bit of hum coming from the speaker. Okay, so yeah, the rectifier tube is pretty hot. The output tubes are cold. They're not hot at all. Rectifier's smoking hot. Okay, so when I turn, I've got it on about 80 volts right now. So if I turn this up anymore, I mean, the light bulb starts really coming on. So there is something shorted, I think, here. So let's try to figure out what that is. You know, since this thing is such a, it is a no name, there's no model name on this thing whatsoever. I mean, there is not a name anywhere on this thing. I was just looking online, and you know, a Fender Bassman amp has some of the same tubes, so I'm gonna kind of use this here at first to generally figure out what I'm doing here with this thing. It's got the same rectifier and basically the same circuit there. I mean, basically. I did already replace the pilot light. And, you know, I was trying to think of what I could do first here. And, you know, since it's obviously something shorted, I think I'm going to start with this filter capacitor. Then on the bottom plate, it's obviously leaking. It's obviously got some goo leaking out of it. And when you, it's unplugged right now. If you, I've got my meter lead grounded over here. So I mean, obviously that's going to be grounded, and then one of the leads to the tube has continuity to ground, so that's obviously shorted. And then the other side, the red lead goes up here to this output transformer. So this thing's obviously shorted. So I'm going to get that out of there. I'm going to bypass it. I'm going to leave the shell of it in there, cut the leads off and get some capacitors in here, and then kind of go from there. What do you think, Leroy?
Okay.
And then I mean, all these capacitors have got to go. These wax capacitors, they're all gonna go. I was checking out the wiring, the way this thing's wired. It comes in from the power cord. Look at this. Somebody put in a new power cord, I think. That's a heavy-duty power cord right there. But it comes in, basically goes to the common lead goes to the switch first, which that's kind of backwards. It really should be the hot wire should go to the switch first, and then it comes back over here and goes through the power outlet, and then the fuse. That's kind of backwards. And then it goes to the transformer, and then the black wire goes straight. Let's see. It's unplugged. Yeah, see, the black wire is going straight to the transformer, the power transformer. That I think is backwards. I would go the other way around. The first thing that it goes to would be the switch. So that'd be like the only live terminal right there. As a way, I'm probably going to end up rewiring that to where that switch terminal right there is the first thing that is hot. So anyway, I'm going to look around through my stock and see if I can find a couple of capacitors. These are 8. You can see that 8 microfarad 500 volt, and it's kind of weird. It's got red black is one section, and then blue yellow is the other section, and the black and yellow are negative, and the red and blue are the positive. You know, I mean, I don't know, maybe that was blue at some point. It's green now, but those are the two positives, obviously, and these are the two negatives coming down here to ground. So I'm just going to figure out some kind of a terminal board or something and get a couple of capacitors in there to bypass that thing. Alright, I just cut the leads off of that capacitor, and there was a terminal strip right next to where, or pretty close to where the other wires were hooked. So I just put the negatives right on that. terminal strip that was basically just being used for the common wire, but the other terminal was just a ground, not being used, so I just went right to that. And then the same with the one that goes to the 5U4. So these capacitors are 10 microfarads at 450. So for now it's going to be fine because I'm on a variac, but eventually I'll get a little bit bigger, a little bit higher voltage capacitors to put there, because the original was 500 volts, 8 microfarads. Okay, so should we try it just to see what happens, Leroy?
Yep.
Seems like the pilot light's a little brighter. The current limiter is not coming on now. That's a good sign.
Yeah.
Not really hearing anything from the speaker at this point.
Oh, lights coming on.
Hey, we got some sound.
Yeah.
We got some sound now. Let's see. Volume control does do something. The microphone volume controls do something. Phonograph doesn't do anything. Tone, tone control's working. A lot of hum, but it's working. Okay, let's see what we can do about that hum. Well, could be possibly this other electrolytic capacitor, filter capacitor, but it's not going to be quite as easy to change. Look at all the junk hanging off of that. What do you think's causing the hum, Leroy?
I don't know.
You think that's what's causing the hum? Okay. Yeah, at this point, I think I'm going to see if I can maybe just jump across something, across this filter capacitor, and see if it makes a difference. I'm not sure. I don't think that these other ones are going to cause hum. Let me think about that. Well, I had turned these volumes, the microphone volumes down, and there was hardly any hum coming from the speaker, so I was thinking that was more like amplifier hum, these other capacitors, not filter hum. So I was going to try to hook a guitar in that phono input, and now I've turned it back on, and there's nothing coming out. So what happened? I was fiddling around with the capacitors, trying to make a list of the capacitors that I need. Kind of guys twisting some of the capacitors around. So I wonder what I did. Any ideas there, Leroy? I've got a little bit of light coming from the current limiter, but not really. Not really enough to be concerned about. Did one of these capacitors fail on me? I bet you that's what's happened. I was just kind of twisting some of these capacitors around so I could see the values, and I turned it back on, and now nothing. So I'm going to try to figure out what's happened.
I don't know. I don't know.
You don't know?
No, I don't.
All right. I just I think we got some dirty tube sockets. I just kind of wiggled the tubes around, and it came back to life. Now see if I turn these microphone inputs down, it's dead quiet. So I'm gonna try plugging a guitar in here just to see what we got. Okay, I've got the guitar. I've got a Stratocaster plugged into the phono, and I got the microphones all the way down, phonograph all the way up. Tone, yeah, let's turn the tone down a little bit. Okay, I got the tone like about 6, and it is dead quiet. I mean, it is dead quiet. So let's see here. Where'd the pig go? I mean, that sounds pretty good. Yeah, I think I'll just, I mean, that sounds pretty good. I think I'll just change out those capacitors under there, and then make a few changes to maybe the tone circuit. And, you know, I'll probably do something with this. Except I'm not sure. Probably make like a, I'll have to look at the circuit and see if there's different different routes through the tubes, the preamp tubes, and maybe make a low and a high input here or something. Change those to guitar. I'll never use this for a microphone. I have no idea what that is. It looks like some kind of a microphone input maybe. And then it's got a couple of phono inputs up here. Why would they have that inside like that? Under the shield. I have no idea. But anyway, I mean, it is dead quiet. This is a Stratocaster under a bunch of, you know, fluorescent lights and everything. So that's pretty good. Don't you think?
Yep.
I was just looking at some of these capacitors. I mean, obviously that one's been changed. That's a new style. And that one looks like it's been changed. And possibly that one. But I was just looking at somehow how some of these are. I mean, it's just like laid. The wire's just like laid next to the lead, and look at that. That's not. Did that come from the factory like that? That's pretty. That seems like that didn't seem that would come from the factory that way. Just kind of laying up next to the wire and solder, but who knows? I mean, that one obviously has got a big solder blob right there. If it'll focus. Yeah, big solder blob. That's obviously been changed. So I'll probably come in here and I'm going to change all these wax capacitors. I'll probably leave that one, and the rest of them are going to go. It's kind of hard working without a schematic. I mean, I don't know what the voltages should be, but I guess if I was working on a Fender Bassman, I wouldn't know what the voltages were on this either, because it doesn't have voltages. So, I'm not sure what to do about that. I'll probably just look at the voltages and then compare like what the maximum plate voltage and that sort of thing should be from the tube manual. I'll get one of these. Actually, I got a bunch of these little tube manuals from the, I don't know if this is from the 50s or 60s or whatever they are, but they say the like for example the 5U4, of course it tells you the base connections, but then it tells you what the filament volts and plate volts, max plate volts, that sort of thing. So I guess I'll just go off of that. But I'm right now I'm just making a list. Just making a list of all the capacitors, and I'm just gonna change them all out, because, like for example, that one back there, I mean, it's just like the wax. It just looks like it has leprosy or something. And looks like this one, the wax is melting. I wonder why they even thought that wax would be a good idea to put on these things. Maybe they just didn't have anything else back in those days. But anyway, that's pretty crappy looking. So, all right. So I was just looking at these inputs, the mic inputs. Well, they go to these unknown. First of all, each one has its separate circuit, I guess you'd call it. They go to these X1 and X2 first. I'm not sure what that is. There's nothing in those. And then the X1 and X2 go to these 6J7s. So each mic input has its own preamp tube. The phono input comes over here to this this tube here. Then I think that right there is going to be like a phase inverter, and then the two output tubes. So each mic has a separate preamp, but then it's got these two. I need to figure out what that is. X1 and X2. I have to research that one. Well, those are 9 pins. I do not know what that is. Is there such thing as a 9-pin? It's like octal, but octal that's 8. So I am really confused at this point. I've been doing some research, and I did find out that this amplifier is actually an RCA model MI 13295A. Yeah, so it's got, I mean, if you look at the grill actually has you can see where the logo, the RCA logo was on this grill. It's been removed. I have one of those. I have one of those logos on a radio, a different radio, so I may take that off. or try to find one. There's one on eBay for $55 just for that. So I'm definitely not going to do that. But anyway, it's interesting. This guy here is this is on antiqueradios.com, looking for a schematic, and you know there really is not a schematic. I've searched around. There's not a schematic online at all for this thing. I did come across a couple of other ones that the X1 and X2 tube sockets are actually for some microphone transformers. I'm not sure exactly what that does. I'm not exactly sure what that does. It may be like a like a phantom power kind of a thing or something. I don't know, but you don't need it because the signal passes right through there. So I'm not sure exactly what those do. People have got those for sale for like $150 a piece. So I'm not sure what that is. But anyway, there's a few other examples of this amplifier out there. There's one on a really nice one on Reverb. The guy completely restored it. I am not going to be doing that. He even repainted all the stripes, the pinstripes and everything. Alright, I guess he added some pinstripes. But anyway, pretty nice. This guy actually, I asked him some questions. This has actually sold, and I asked some questions about it. He wasn't able to give me a schematic or anything, but he did let me know about those transformers. And there's what he sold his for. So anyway, he's got a video on here. Little demonstration. It sounds pretty good. So anyway, I've been putting 1/4-inch jacks. I replaced these speaker, these worthless speaker jacks for some 1/4-inch speaker jacks, and then also changed out the mic, the XLR inputs for some 1/4-inch jacks. I just got a piece of metal and riveted that in there. I do have a little bit of a clearance issue right there. That's kind of close. I'll probably put some plastic or something there just to make sure that someone doesn't... I don't think it's going to do anything because I don't think there's any juice there without that transformer. That's the jack for the microphone jack transformer. So anyway, so I got my order of capacitors in a couple days ago, so I'm gonna have some fun putting capacitors in. Ordered some extra ones just to cover the shipping for the next ones. So anyway, I'm gonna have some fun putting capacitors in. Probably start with that one back. That fried one back up there, that melted one back underneath there, and then kind of work over here to the side. So anyway, I won't bore you with that. There's about 1 million videos of people changing capacitors. So probably some of them for the most part I'll just J-hook in there. That's a perfectly acceptable way of putting capacitors in. If it looks easy enough, I'll actually completely remove the capacitor and then change out the the leads, but for the most part I'm probably just going to J-hook these in here, but we'll see how it goes. I've got this first capacitor out here. I just thought I'd check it real quick just to see. It's supposed to be a 0.02. Let's see what we got here in the checker. Whoa, ESR 59 ohms. Yeah, 91. So it's about half of the, it's almost not quite half of the capacitance it should be, and it's got 59 ohms resistance. So that's definitely bad. Yeah, and that, let's see, what is that? That's on the output tube over to the over to the 500 ohm. I'm not sure exactly what that does. It's on the to the 500 ohm output on the output transformer. So I'm not sure what that does, but anyway, it was definitely pretty pathetic shape, pretty bad shape. And just for comparison purposes, let's see what the new one checks out. Right on. Why doesn't it show the ESR, I wonder? Anyway, that's the right value. Just look at this thing. It's just, I guess that's all they had was, back in those days in the 50s, that's all they had was the wax. But man, that seemed like they could have thought of something better than that. That's just, look at that thing. Well, this is where we're at so far. Got almost all the capacitors changed out. Got that one, which is kind of a tricky one. And then I've got this one down here to do. And then I'm really dreading this mess right here. This is a can. It's got 4, I don't know if you can see that, 4 5 microfarad capacitors in that can. And I'm debating whether or not to change that out. This thing's quiet, but I probably should change it out. And I've got the replacements here. I'm just going to put 4 capacitors on the bottom. Man, that resistor looks fried. So, you know, these are the ones that have come out. I've tested them all. They're all bad. This one is just like completely bad, big time. That one's just completely open, and the rest of them are just way out of spec. So I did originally, you know, I had these little bitty 10 microfarad 450 volts in here to replace that can. So I got me some big, and I'm not sure why the size difference on these things. I mean, it's only, you know, a difference of 50 volts, so I'm not sure what that's about. These actually seem kind of small. They're Nikons though, so I don't know. But anyway, it works great. So far, so good. So I'm gonna finish up, get that one replaced, and get those 4 right there. I'm not sure how I'm gonna do that. I may have to put in some kind of a terminal strip or something. I can use, see those tabs. Of course, I'll cut that out of the circuit. Then I might use those tabs to ground to or something. I'm not sure exactly what I'm going to do. And then once I get done with that, I'm gonna go through and test all the resistors, make sure they're in spec, and then see what happens. I never did find a schematic for this thing, so I'm just doing each capacitor one at a time, and then testing it after each capacitor I change, just to make sure I'm being very careful to get the right values in there, and I'm testing like 3 times, 3 different checkers, just to make sure I've got the right value. Since I don't have a schematic, I don't, if I screw up, I'm not sure what I would do. I guess I could just draw out the schematic myself. But anyway, I'm just testing it after I change each capacitor. So, and so far so good. I'm also, modern capacitors are not, the outside foil is not marked on these things. So I'm also going through and see that dot right there. I'm going through. There's a YouTube channel, Mr. Carlson's Lab, that shows you how to determine what side of the capacitor is the outside foil, which makes a big difference on amplifiers. You really should have your capacitors in the right way so to reduce the hum. So I've been testing each capacitor and marking the outside foil with a little dot so I can get it in the circuit the correct way. And some of these things have been, to me it seems like they're backwards. The outside foil is supposed to be to the lower gain part of the circuit, and it seemed to me like a few of these, actually quite a few, were in there backwards. I don't know, maybe it doesn't make that much difference, but anyway, I tried to get them in the right way. There's a video on Mr. Carlson's Lab, something like are your capacitors installed backwards, and he shows you how to check them, and also how to build a tester. Also on his Patreon, he's got I think he's got a circuit board and an actual, like an automated tester to check your capacitors. Anyway, that's where we're at. Oh, and another thing, I usually try to, if I can, put the value of the capacitor out so it's easy to tell what the value is. But some of these, like for example that one, the outside foil was on this side of the capacitor. So I guess I could still bend this around that way, but I don't know, just get it out of the way. The writing went toward the chassis, and there's actually quite a few other ones like that. So normally I try to put them out so, like, if you ever get back in here, you can see what values are in there. But on some of them, it wasn't really convenient to do it that way. So anyway, whatever. So this is how I'm determining the outside foil for the capacitors. Just hook your leads to your scope. Okay, so hook the capacitor up to your scope, and usually I just hold on to the capacitor just like this, just like that, and then look at the scope. But there's just not much of a reading on there, and that's weird how that's blinking out on the scope. But also I just have a fluorescent light under here. So what I was doing was holding one hand hold on to the capacitor, and the other hand I have a fluorescent light under here. So I just put my hand up near the fluorescent light, and it makes a bigger wave. But also what you can do is just hold the capacitor up there. Okay, so see, and that's blinking out, but so you see you got a pretty small wave. Okay, so let's turn this around, turn these leads around. Should I get a tripod for this?
Oh,
Okay, turn the leads around and then do the same thing. Put the capacitor up there, and see you got a much bigger wave. I'm just holding the capacitor up to that fluorescent light. So look at that. So see, so in that case, this side's the outside foil, the black ground lead. Okay, and if we look at that again on the scope, put the thing up by the light. See, it's a much smaller wave. So this is the outside foil right here, the black lead. So I just put a dot right on the end of the capacitor, just like that. And that way, when I use this capacitor, I'll know, oh, hey, there's the outside foil. I'll put that on the lower impedance part of the circuit. So, anyway. Oh, this 100 microfarad is testing at a 30 picofarad. So that's also the it's on the 6SF5, which is that. So it'd be a cathode bypass capacitor. So that probably will make a difference. We'll see. There's something, this is how it's been all along. I don't know if you can hear that. When I touch the inputs. But there's something here, and it seemed like it sort of got worse when I changed out this bypass cap. There's a short here somewhere. Okay, there's a short there somewhere. So now, see, now the volume seems a lot more like what it should be. It's a lot louder. So there's some short I'm tracking down here on this tube socket. Oops. I've got half of the leads off of this capacitor down under here, and so I'm just testing it just to see what it looks like. 10. It's supposed to be 5. ESR, maybe a little high. V loss, I'm not really sure. 3.5%. Anyway. So the other section is a 13, so it's higher, and the ESR's higher. The V loss is about the same. The resistor is coming up to 5,400 ohms. It's supposed to be 4,700, so it's at 10%. So that's a little bit too high. Unfortunately, I don't have another one of these. I'm going to have to order that, but I'm going to put this back in for now. Okay, this is another section. And the ESR is not too bad. I'm not really sure about the V loss. And then the last section is about the same. They're all about the same. So, that really not all that bad. And that, that's probably why there's not very much hum. But anyway, I'm putting in some new capacitors now. And I just cut those away, and I'm gonna put some of these terminal strips in there to attach the capacitors to. Even though the capacitors didn't really test that bad, there is some unknown substance leaking out of the capacitor, so that those would have gone bad eventually. I mean, they would have probably shorted or gone open eventually, so it's just best to get that out of the circuit. Okay, all the capacitors have been changed, and I turned it on, and I was just kind of tapping around. I just noticed like when you would just touch it, you know, just like tap on it, it sounded like something was shorting. And I just kept looking around, and I went through and tested all the resistors, and this one right here was giving me some really weird readings. It's just a 104, so that would be 100K, right? 104. Yeah. This one over here was fine. That one right there was fine. This one was giving me just weird readings. So I was looking at where these were attached. See, this one's attached right there. And it looked like this one was attached there, but it wasn't. It was just pushed over and touching. It was touching that terminal. So I just bent that over. And that fixed the. Let's just turn it on. Before I was before I was just tapping like this on the chassis and getting all kinds of weird crackling noises, but if we turn that on, probably helps when you turn it on. Sometimes they work a little bit better when you turn them on.
Yeah.
I found a little bit louder when you turn them on.
Yeah.
It's quieter when it's off.
That's the truth. Definitely.
Oh yeah. So it's actually that's an issue I've got. When you turn it on, there is a pop. There's a pop after about the first 10 seconds. So that one I still have got to figure that out, what that is. But then when you tap on it, when it's been running for a couple seconds, you know, it's fine. And that turned out that was just that resistor had been pushed over there. And I don't know, it almost looked like it was that way originally. So I don't know if this thing's always had a problem or what. There's another weird thing up here. There's this terminal board that looks like nothing was ever hooked up to it. So that's kind of strange. I was looking at that because this has a resistor. This 6L6 has a resistor going to ground, and this one has the same resistor, except it's like a big huge one. I'm not sure why that is, but this one also has a capacitor, so I got to figure out what's up with that. So I went through and tested all the resistors, and they're pretty close, not exact, but with probably 10%, maybe 15%, except for these right here on the volume controls that go to the grid of the second stage. I think this is the phono volume control. I think that one's fine. These two here, they're supposed to be 220K, 224, yeah, 220, but they're way off, and I think that's causing this. If you listen, I've got the volume turned down, and on the channel, what is that? 1. I mean, you can turn it all the way up, and it's going to be loud. The volume control for microphone 2, if you turn it up, it's good. Until you get to about 8, and it goes into some kind of wild oscillation. So I think that the next step, I'm going to change out these resistors that go from the volume controls of the microphone to the grid of the first stage, which I haven't done a schematic on this yet, but I just kind of mapped it out. The the microphone 1 and 2 go through the 6J7s first, through the volume pots, and then to this second stage, 6SF5. The phono goes straight to that with no stage before the 6SF5, and then they go to the to this other stage, which I think is the phase inverter, and then to the 6L6s, basically. And it's sort of similar to this right there. This is from a basement amp schematic. It's kind of similar to that. You can see on this is a double. Yeah, a twin triode. Yeah, this is a twin triode, and this 6SL7 is also a twin triode. So it's kind of sort of similar, and it would function as the phase inverter. So it's similar, except this one's got the tone control somehow in the mix there. So that to me seems like it would just make half of the signal be affected by the tone. And why would they do that? I don't know. That seems kind of odd. Anyway, I'm still going through this. The next thing I'm going to do, though, is change these resistors right here to see if I can get rid of the oscillations, and also probably test those 6J7s, because it seems like one of them's got a lot more volume than the other one. But that could just be these resistors. So that's what I'm going to try next. Okay, I got this problem where there's channel 2, and they're the same. Well, no. I mean, they're the same volume, essentially, but I mean, volume on mic 1 on channel 1 is a lot lower than channel 2. And you know, it's essentially the same. There's nothing to it. There's nothing to it. So I don't understand that. I don't think it could be that pot. Maybe it's the pot, because it's coming in. Has that pot gone bad, Leroy?
I don't know. It might.
Okay, well, I have to check that pot out. But then I also get this problem over here. I just noticed that when that flexes, something is wrong here. So I gotta fix that. I don't know if it's just a cold solder joint or what's going on there. What do you think, Leroy?
I didn't do that wrong.
I don't know if you can see that, but whoever put this capacitor in, all they did was just stick it through the hole and put some solder on it. It was the same way over here, so I heated up the solder and then curled it around. I'm going to do the same thing here on this side. I'm going to just curl that around a little bit. Because you need to have a mechanical connection as well as just the solder. I think that's what that was. I think it was this side right here, but we'll find out here in a second. Oops, wasn't even recording. So I just hit those. Actually, whoever had put this capacitor in had just stuck the lead through the terminals and just soldered it, and terminals, or the solder had cracked over time. So what you really need to do is make a mechanical connection and then solder it. So curl the, make sure you curl the leads or whatever you're soldering around the terminal first, and then solder it. It's kind of a pain in the butt if you ever have to take the part out, but over time it makes a lot better connection. I just hit all the solder connections there with a little bit more solder. Make sure they were all good. I've still got the problem over here. Channel 2 is loud, channel 1 is not. So I'm not sure what, unless it's that pot right there. Okay, what it was this, that lead right there just wasn't soldered good enough, and I did that. That's when I replaced the filter capacitor, and the lead channel 2 I noticed was kind of humming, and channel 1 was quiet. And it turned out that red wire right there, going to pin, what is that? 8, 7, pin 6. Pin 6 is just a ground. It's just a ground. Yeah, see, those all go to ground, and it just wasn't connected. It wasn't connected over here at the filter capacitor. So that actually made channel 2 work better and channel 1. So now there's channel 2. That's actually all the way down. Let's put it on 1. Got a lot of signal there. Let's put this on 1. And it's almost exactly the same on 1, so that's fixed. All right, Leroy.
Good.
I think we're ready to test this thing out.
Cool.
All right, I'm just going through here, just checking some voltages, and on the output tubes, on the 6L6s, I mean, it's showing 340 on both of these, but it's current limited. I'm still going through my current limiter. When I take it out of the current, off the current limiter, it's like 450. And the 6L6 supposed to have a max plate volts of 360. So it's coming from, obviously it's coming from this output. Dang it. From the output transformer. So, okay. How do I bring that down? Is it one of these resistors right here? Might be that one right there. Let me check this out. I don't have a schematic. I just got this. I'm kind of going off this basement amp schematic. I mean, it's basically similar. So the voltage would come off the center tap. Let me look into that. The transformer that feeds the power tubes, the 6L6s, the power is coming from this big resistor, and it's hot. I mean, it's pretty hot, but it looks like it's supposed to be hot. 'Cause you see, I don't see if you can see those vent. There's some vent holes in the chassis there, so it's like they knew that was going to be hot. And I really can't tell. I mean, this is 3,000. Is it 3,000 ohms between those 2 points and 20,000 between those two? I have to check that. Anyway, when you plug it in straight to the line, I get 450 volts. 450 volts on the plate. And here's another schematic. I was looking at some 6L6s, and this has got this one's got 412, so maybe that's all right. I mean, I'm higher than that. But anyway, he's talking about, he's got some information on the biasing. I might just try checking the bias to see how that looks. This is a M Power Model 80 tremolo. So I mean, it's not quite this part of the schematic. This part of the circuit is similar. I mean, I don't have that. That looks like that's for tone or something. So I think I'm going to try checking the bias to see how that looks. Okay, I did a bias computation. The bias resistors on the first tube is 65, and the second one's 51 volts. Voltage drop is 4 and 3 volts, and the plate voltage on both of those are about 450, which seems really high. And then the watts, they're both about 27, 28. So that, I mean, that seems, if you look at the tube manual, depending on whether it's a Class A, AB, or AB2, it can go from 6 to 47 watts. And this is the General Electric tube manual. The RCA tube manual's got 18 for Class A, 24.5 for Class AB, and AB2 is 47. So I'm going to have to figure out have to do some research on what class this amplifier is. I do know that that's fixed bias. It's definitely cathode biased. I do definitely know that the plate voltage is high, because I'm getting 450, and the highest that either one of these manuals is showing is 360. So I think that's coming from this big resistor right here. This thing checks out, I think it's supposed to be 20,000 ohms, and it's coming out to 15,000 on this section, and the top section is 27. So they're both low. So I'm just thinking I should put another, maybe just add to this resistor, because that's what feeds this output transformer, and that's where the voltage comes for the two. So I think I'm gonna play around with that and see if I can bring the tube voltage down, and then that'll bring I think that'll bring the bias down a little bit. So I think I'm gonna give that a shot. Okay, well, I was kind of worried about the plate voltage being too high on the 6L6s. They're both showing about 450 volts and about 27, 28 watts of plate dissipation. And I was, I'm looking at this is my tube manual, and I was looking at the plate volts, and the max on this is 360, but this is for a 6L6. 6L6, and what's in the amp are 6L6 GCs. So I was looking around, and here's this is a tube manual, a tube data sheet for a 6L6 GC, and it's showing 500 volts and 30 watts plate dissipation. So, I think I'm okay. I'm about 10% under the maximum watts, and about 10% under the max volts. So I think it's going to be okay. So I think what I'm going to do at this point, I think I'm going to replace that capacitor just so everything will be new, brand new in this thing. I'm sure that's fine, but I'm gonna go ahead and change it out since I've done all the other ones, and then just call it good, because it seems like it's working pretty good right now. So that's what we're gonna do. Okay, I went through and cleaned the chassis with some just some household cleaner, and one thing you've got to be careful with is on these the letters. A lot of times they're oxidized. They'll be oxidized, and they'll just wash right off. So try someplace in the back first before you get too aggressive with the cleaning. But these are all in really good shape. So so I use some household cleaner and then car wax on the chassis just to protect it from any corrosion, and kind of buff it out a little bit. Looks pretty good. I'm not too worried about those scratches. It shows its age. It's from the 50s. So anyway, look at those transformers, and look at those shiny tubes. So anyway, I found this RCA Emblem on Etsy. It's actually it's a keychain. The vendor actually has all sorts of different emblems and logos, and I bought this keychain and just filed off the keychain part of it and stuck it on there where the old logo was. There are some original ones on eBay for like $55, and I didn't really want to spend $55, but this was about $10, I think. It looks pretty cool. Kind of gives a new look to it. Okay, I've just got this my line 6 pod plugged in, coming out of the stereo out into the two, with a Y cable coming into the two mic inputs here. Both of these set on 3. Anything above that, anything about 5, it gets pretty distorted. And this thing, I know you can't tell this from the video, but it's loud. This thing's really loud. Phonograph, if you plug in the phonograph input, it's really clean. It sounds really good, really quiet. Tone, I've just got on 5. I don't know if you can hear some amplifier noise, not humming, but just shh. And that's partially because of this. The output on this pod is a little bit high. I've got it on about 3 or 4, Well, that doesn't make any difference. I don't know. So I'm not sure what that's about. It's just the amplifier noise. But anyway, sounds good. Actually, anything over about 2.5, you kind of get that amplifier noise. And it's loud. You can't tell that, I'm sure. But it's loud. So that's a clean, it's got a really nice clean tone. So it would be great for, I mean, you can turn it up. If you turn it up to, when you get a lot of amplifier noise, it's loud. I mean, it's loud as all get out. So I'll keep that about down to there. So, you know, I've got both channels going here. If we just do one channel, what's it sound like? A lot cleaner. Seems like channel 2 is more distorted. It's probably just a result of just a different preamp tubes on each channel. So anyway, there you go. I've just got this pod on clean. I put a little crunch in there. Let's see what we got. So this would be a good amp for using pedals, or just, you know, if you wanted to play clean. It's definitely loud enough. My ears are ringing just sitting here in front of the speaker, so it's pretty loud. Anyway, there you go.